it should be covered all the way down to China with an
Yeah.
ice sheet.
Yeah.
Similar like let's say down in the US, it almost came halfway the US.
I know.
So
Down
it's
to very, very warm areas. I mean, areas that are very warm today.
yeah. So the Midwest, let's say, of the United States was almost covered with a large ice sheet, but that should be the same for Russia.
Yeah.
If this was an let's say pole, our current geographic pole, was on this position. So
Mhm.
this is strange as well. So one thing, Milankovich doesn't explain it, and secondly, the ice sheet was very eccentric. So these are two things that are weird.
Welcome to Mind the Shift. I am Anders Bolling. In this episode, we're going to learn about a theory about the Earth's geological history that is utterly, completely radical. And I would say that most geologists and paleontologists would probably call it outrageous. And myself, I also find it almost too strange to believe, but I've come to realize that I'm suffering from limiting beliefs, like most of us are, and I mean, anything is actually possible in this very strange and rich reality that we're living in. Plus, we know much less than we're led to believe about what actually took place on this planet until about, say, 10,000 years ago or so. So, welcome to the show, Martin Deche, aka Mario Buildreps.
Thank you, Anders. Thank you for having me on your show. And it's nice to have a talk.
Yes, it's going to be very interesting. And we can start with your name there. Martin Deche, it's a Dutch name, but you have a pen name, Mario Buildreps. Can you tell us a little bit about how that all started, why you use that name?
Yeah, it's not a very long story, because I discovered my theory about 10 years ago. So I'm already almost 10 years busy with this work. And when I first discovered the main core of my theory, I thought, okay, this is weird, but I have to write something about this. I have to publish something about this, but not under my usual name, because for two reasons. My name is impronounceable for foreigners, for English speakers, and I published it in English. And secondly, I thought, oh, a lot of people know me, and so this outrageous idea could offend people in my surroundings. So I thought, no, Mario Buildreps is a nice name, and Buildreps stands for building reports.
Mm.
So it's not directly about ancientity, it's about reporting about buildings, and then
Yes.
specifically ancient buildings.
Yeah, and we're going to come back to that, of course, because that's a huge part of your theory. But you have you wrote this pre-interview form, so I know a little bit about your background. You have a background as an engineer, I understand, and you've been interested in ancient history and things like that for a long time, haven't you?
Yes, I've been interested in ice ages, Neanderthals, in the stone tools, in how did people live in the ancient times, and how did they cope with their environment, how did they cope with difficulties, how did they how did they live in general in this weird times, and I often pondered about this when I was a young child and when I was adult. Of course, when I was very busy having a career, I forgot about this. Busy. But then I ran into difficulties in my private life about 11 years ago. And then I thought, okay, what did I actually want when I was young? I thought I wanted to be archaeologist or a scientist or a geologist, studying ancient people, studying ancient artifacts, and also dolmens, and we call this hunebedden in Holland. We have a lot of hunebedden in Holland.
Mm.
I lived in the northern part of Holland when I was a young child, and there were a lot of hunebedden, and hunebedden is the Dutch word for dolmens.
Okay, so those are stone structures, simple stone structures, like two big blocks, and then there's a third block on top of it, or something like that.
Yes, but we have a large collection in northern part of Holland, and they are extremely heavy and big. So I wondered as a child, walking over these big stones of the roof, this jumping from stone to stone, and then wondering, how did these people, ancient people, do this? How did they raise these standing stones and then lifting this? And no one, of course, there was a museum in the neighborhood, and they explained they did it with sticks and stones and lifting. But some stones were 10, 15 tons, so that is pretty heavy for lifting with bare hands. So
and at that time, when this happened 11 years ago, you were working you were a businessman, I understand.
Yes. I had my own company.
Your own company, okay, yeah.
And you just stop this from day 1 to day 2. Quit my job. I said goodbye.
To follow your dream.
To travel. I'm going to live. I'm going to explore. I'm going to do things that I like to do. And then after a year, I came back. And my pockets were empty, but my spirit was full.
That's wonderful.
So I came back as a sort of rich man, and
and this is what you've been doing for the last 11 years. You've been doing this research about ancient geological history of Earth.
Yes, it started mainly. It's a good question. It started with the questions about ice ages, and I have an uncle who's a geologist, and I often wrote with him through email, and of course we met sometimes, and we had a discussion about CO2 and about ice ages, and he said, no, ice ages is just Milankovich cycles, that's all, and CO2 is bullshit. Climate change about CO2 is bullshit. And so I thought, he's a clever guy, so I thought he must be right about this. But then I discovered, of course, my theory, and I started to talk about him, about maybe there were pole shifts. Because I forgot to tell this to you, I also learned to read about Charles Hapgood about 10, 11 years ago.
Hapgood, yes. Hapgood. Yeah, I just recently read about his work a little bit, yeah.
And Hapgood did a tremendous job, especially in his time in the late 50s, when he published about the shifting crust, and also read about this. And I talked to my geologist uncle about this. He said, "No, it's bullshit. It's impossible." Maybe he's right, maybe he's wrong.
Everything is impossible until it's proven.
Yes, exactly. And then I started reading the book of Hapgood in its details, and I understood he had some point somewhere. And also there were a lot of problems with his theory. But I thought, okay, 2/3 of the landmass are on the northern hemisphere. So if this northern pole had shifted in the time frames Charles Hapgood talked about, it might be visible in the orientation of ancient structures. So when I was young, when I was studying, I often looked in the sky, and then I saw condensed stripes of airplanes. And sometimes 2 stripes cross each other. And that is always possible when you have converging courses. But when a 3rd airplane crosses the same point of crossing of the other two planes, then you can say this is not very coincidental. There might be a beacon underneath, because airplanes fly over beacons. So they navigate through beacons. There's a beacon here, beacon there, and they go from beacon to beacon.
Yeah.
And when you see this crossing point, it's not exactly above this beacon because they have a sort of radius. But you can say, okay, these airplanes are crossing over beacons. And the same thing you can say about the orientation of ancient structures. When two structures cross each other, you can say, okay, this is just normal. But when the third one crosses the same spot, the same area, you could say, it's interesting because it can be coincidence, but the coincidence, how do you say this in English?
Yeah, coincidentally, or the likelihood of a coincidence.
The likelihood is better. The likelihood that this could be a coincidence already diminishes.
Yes. And
the more crossings over this typical point, the less coincidence it is. So, okay.
Can we just back up a little bit here, because now you're delving deeply into your theory already, and it's wonderful. But
not yet. I'm going to be much deeper.
Yes. Into the theory. Yes. Okay, but just to back up a little bit, because I don't know if my audience is a broad and a diverse audience, but I think most of them are not extremely knowledgeable about the theories about ice ages, because I mean, at the core of your theory is how have ice ages been formed, and how is this shown in, as you say, the orientation of very, very ancient structures. But the standard theory now, the standard idea about ice ages is probably, as your uncle said there, as far as I understand, the Milankovich cycles, and we're talking about 3 cycles. I think the wobble of the Earth's rotation around the sun, what is called the ecliptic. There's a wobble there, and there's the precession of the equinoxes, and then there's the wobble of the angle of the Earth. Those are the 3 Milankovich cycles, and they have different lengths. And so, according to the standard theory, is it fair to say that this is what people say in textbooks, that is what creates ice ages? Is that right?
Yeah. Yes. There is but there is a lot of controversy about this
explanation. Yeah, it's a theory. It's not really proven, but it's like everybody believes it. So
it's not proven. I can explain your audience. Thank you for this question, by the way, and it's a good question.
Well, just to give the foundation, to lay the foundation for what you are talking about.
Yes. Milankovich is about what you say about the wobble of the Earth axis. So it goes every 24,000, 25,000 years, approximately.
Yeah.
And then it is the change of the tilt.
Yeah.
So the Earth axis is tilted, currently about 23.5 degrees, and it goes to 22.5 up to 24.5. So it wobbles a little bit.
Yeah.
And then there is eccentricity around the sun of the orbit. Like a comet also has an eccentric orbit. The Earth also has eccentric orbit around the sun, and this varies. And so these are the 3 main parameters of Milankovich cycles. And this theoretical model, mathematical model of Milankovich should explain why ice ages come and go over the 100,000 years. But there is a problem with this, because they call it Milankovich. You can say around the polar circle, there is a so-called insolation factor. And that is the amount of solar energy that comes onto the Earth around the Arctic Circle. And these 3 parameters of Milankovich, you can calculate this. It's very difficult, but you can calculate the amount of incoming solar radiation around the Arctic Circle. That is also around Greenland and so on. And then try to explain that this varying solar energy could explain the ice ages. But the variation is so little that you cannot explain this, the coming and going of ice ages with this tiny variation. That is one. And so you can, let's say, draw a graph of ice ages coming, ice ages going, coming, going, and so on. And then you have the 3 Milankovich cycles. And then you have, on top of this, the solar radiation variation. And this is a sort of sinusoid wave.
Yeah.
A little bit variation, but it doesn't match. Totally doesn't match. So, and this insolation factor is greatly exaggerated, like in stock exchanges. Because if you, let's say, in stock exchanges, they blow up the scale, the Y scale. So then you can see the variations. But if you make the true scale from 0 to the top of the variation, then you see a little bit variation, but almost a flat curve. And when you, let's say, project this curve onto the ice ages, there's no
correlation.
No correlation at all.
Okay. So do experts know this, what you're talking about now, but they don't really want to talk about it because they think it's uncomfortable, that it doesn't...
Yes, a real problematic topic, because ice ages are never well explained up to this day.
Yeah. But you have this explanation, which is, I mean, it really fits what you have found really fits your theory. And one might say that you have picked the evidence according to your model, but I think that goes for any model anyway. So, and in short, and here it comes for the audience, be prepared now, here it comes. You propose that what we call ice ages have been caused by a recurring expansion of the actual planet. Is that correct?
Yes, this is let's say the final conclusion.
Yeah.
So.
And how have you seen this, and how have you corroborated this?
It's a long way to get there.
Yeah.
It's a long way to
where
get
did
there.
It start? Did it start by you watching looking at these ancient structures, or where did it start?
Yeah, where did it start? It's a long way to come to the final conclusion, and I want to say I love to know the truth. I'm not looking for, let's say, expanding myself to the audience with a bullshit story. So I'm looking for myself. I want to know the truth for myself. How is it? What is the actual truth about our ancient history, about what happened to the Earth, what happened to the ice ages? I want to say one more thing about the ice ages. There's another thing, not only about Milankovich cycles, not explaining the waxing and waning of ice ages, but also the outrageous eccentricity of the large ice sheet.
Yeah.
And
yeah,
I can pull this up from my website, maybe.
Yes, we let's look at that in a while.
Can I show this?
That's really strange. I've been thinking about that too. It's very strange how it. I mean,
yeah.
How it's skewed towards one side of the Earth.
Yes.
Yes, here you can see it very clearly.
Is a sort of condensation of everything, but let's look at the white area. That is the ancient ice sheet, and this red dot on top, pole 1, current pole position, red circle.
Yeah.
So this is the actual difference between the location of the large ice sheet that started to melt about 20,000 years ago, up to 10,000 years ago. And so it's a very strange eccentricity of this. And when you look at the growth of ice and snow formation every season on the North Pole, up to Russia and up to Canada, United States, it goes fully centric. I mean, it's fully centric around the pole 1, our current geopole. So this is actually normal because we have an
You mean
Arctic
a normal
Circle.
during a normal winter, you can see the ice formation is centered
Yeah.
around
Yeah.
the pole that we have right now. So,
Yeah.
but the expansion of the ice sheet during the last ice age doesn't make sense if you have the pole where we have it now.
No.
Because it's almost all of the ice sheet
Yep.
is on top of North America and Northern Europe. And do you have a picture of the Earth on the other side so we can see how little ice it was on that side?
I don't have it prepared.
But there
right
was
now.
basically no ice like on Kamchatka
No,
or those parts.
because if you would expect that Russia was entirely covered with an
Exactly.
ice sheet,
Yes.
but it was not. It was just the northern part of Russia, a very small part was covered
Northwestern
with
parts, maybe. Yeah.
yeah, but it should be covered all the way down to China with an
Yeah.
ice sheet.
Yeah.
Similar like let's say down in the US, it almost came halfway the US.
I know.
So
Down to very, very warm areas. I mean, areas that are very warm today.
yeah. So the Midwest, let's say, of the United States was almost covered with a large ice sheet, but that should be the same for Russia.
Yeah.
If this was an let's say pole, our current geographic pole, was on this position. So this is strange as well. So one thing, Milankovich doesn't explain it, and secondly, the ice sheet was very eccentric. So these are two things that are weird.
Very weird.
And in the center of this large ice sheet was Greenland. It was the center part of this, let's say, expanding ice mass.
Yeah.
And that's interesting. So, okay. Back to your question about, shall I stop sharing?
Sure. We can come back to these pictures.
Yeah. So we can see each other. Back to Hapgood. Hapgood did some, not some, a lot of research about this crust shifting, and the crust shifting in its totality. So that's also Antarctica shifting, and he had a mechanic explanation behind this, because he said, okay, you have the sort of, I don't know the English word for this. I just forgot it. But this, if you take a bucket full of water, and you swing it around your head, so the water keeps staying in the bucket. You know,
the centrifugal.
Centrifugal. Yes, thank you. And Hapgood explain this when ice masses, a little bit eccentric, form around the North Pole or South Pole. It generates a large force, a centrifugal force, and this centrifugal force just tips over the crust. Could be. I really was intrigued by this idea, because he had also some sort of a friend he helped him with this theory, and he made a sort of model how this centrifugal forces could indeed cause this. But then I realized, reading his book, there were some serious problems with his theory.
Yeah.
And because he said this all crustal deformation or crustal shift happened over the last 30 to 40,000 years. And that's a real problem, because Antarctica, we know this is blue ice. Antarctica is already 2.5 million years old. So how if this crust tipped over, like Hapgood suggested, then Antarctica should melt, and there's no way to have to
It should
have
have
this
melted
mechanism.
regularly during that period, you mean?
Yeah, sure. And so
But we know it haven't. It hasn't. It has been covered with ice for at least 2 million years.
Yeah.
Okay.
And drillings make this clear that although the climate very much changed, so let's take this in. I took this in my back of my mind, and thought about this.
Yeah.
I thought a lot about this, and I'm also not only a thinker, but some people call it overthinking. I'm also a spiritual guy. I meditate, I do yoga, and I ask, let's say, the higher realm for advice and for guidance. And of course, in the scientific world, this is bullshit.
Yeah.
But for me, it's not, because
Me neither.
I know. I read your blog, your website. So that's why I found it very interesting to talk to you, because I'm not a believer, but I'm convinced that the essence of our universe and our being is purely energetic.
Mm-hmm.
It's pure energy, and so energy is mathematical and vibration, and that's the essence of everything. And so I am convinced that when I have serious questions that I cannot solve with thinking, I just ask. Let's say I put out my antenna,
Mm-hmm.
and then ask a question. And sometimes get immediate answer, and sometimes it can take a while. So let's go back to Hapgood and his shifting crust. Hapgood suggested that this crust tipped over a few times. And so he had projected a few north poles, one on Greenland, one on around close to England, one in I believe the Hudson Bay, and another one somewhere else. And I thought, okay, if this happened over the last few 10,000 years, there might be signs of ancient foundations orienting to these poles of Hapgood. And already knowing that the ancient ice mass had its center point on Greenland, and Hapgood also had a pole on Greenland. So I thought, this is interesting. So there might have been a geographic pole on Greenland. I didn't know the mechanism behind it.
But you mean when you're talking about structures being oriented towards this, that's based on the idea that people have always built buildings oriented towards true north? Is that your thought here?
Yes, not always, but I realized that there might
it's a
be
common feature anyway.
Yes, a common feature, and you can solve this problem by doing a lot of math to be sure about this. And for example, the pyramids of Giza are very nicely oriented to our current geographic pole.
Which means that they are not built, 50,000 years ago, because then...
No, you can say this for sure.
Yeah.
You can say for sure they're originally built within, let's say, maximum 26,000 years ago. Probably younger. Somewhere in the range of between 10 to 15,000 years ago.
Okay.
This is the most probable time frame they're being built, and I can explain it. I'm writing a book, of course, and I will explain this all in detail why I think this. It has to do with also the rotation of the African plate. So they have built this pyramid very exactly oriented to current north or current wind direction, cardinal directions.
Yeah.
Within 0.05 degrees. That's extraordinary. How do you do this? Sticks and stones. Because there are ideas about this.
And there are all sorts of calculations you can do from the pyramids about the dimensions of the Earth and distance to the moon and distance to the sun and everything. I just listened to this actually, but that's a sidetrack.
Yeah, it's very interesting because it would suggest that the meter was already present and that they already knew about the speed of light. That there are a lot of signs, let's say a lot of red flags that our current explanation of ancient history is incorrect. But okay, this is a side step. So, okay, I started to look at the orientation of ancient structures, and I started to build a database and of just going to an ancient structure in Google Earth, not physically. If you stand physically at a structure, you're overwhelmed by the size. You have no idea where geographic north is, because if you take your phone or compass, your compass will be directing you to the magnetic north, and not to the geographic north. And this is different.
That's right.
It's also interesting.
Good point. Yeah, good point. Yeah.
Two different things. Magnetic north is let's say an imaginary north. It's not physical. And the geographic pole is a physical pole. It's the pole around which the planet rotates.
You will only notice it when you see the sun rise on the spring equinox, for instance. Then you can see it's aligning with the pyramid or something.
Yes, yes. So if you, let's say, I don't know, I have no, you say this in English. I have no comment about the advancement or the sorry for my stumbling. How much advanced ancient structures, ancient civilizations were. I don't know exactly, but if you want to know seasons, if you want to know time, if you want to know the time of year and so on, and you have no watch, no calendar, you will be looking to the sun. You will be looking to the sky, to the geometry of the sky.
Yeah.
Where is the sun rising? Where is the sun setting? And how does it change on the horizon? And then you will understand when the season changes, when the winter solstice is, when the summer solstice is. And this time of year is decisive for, let's say, harvesting, for sowing, for all kind of interesting things you need to do for, let's say, continuity of your civilization. But okay, so I don't know about this exactly the advancement of a society, of a civilization, but I understand, okay, if they have no calendar and no watches, they might be having their time from the sky. Yeah. So they might have been orienting to this ancient pole. Just take a drink.
Yes. And you looked for this orientation all over the world on Google Earth, and you found clusters of structures that were oriented towards different points, different north poles.
And Google Earth, our satellites have done a magnificent job because you can very accurately measure the orientation of structures in relation to our current geopole. So I started building a database. I initially had 100 structures and already saw a very rough pattern of clustering over Greenland, and then started to go to 200, 300, and now almost 1,200 structures. And the more structures I gathered, the more, let's say, pixelized this poles became.
Mm-hmm.
And there's some
more finely tuned, more exact, or more.
Yeah. So I developed some math around this about where are two structures crossing each other's, let's say, northern extensions.
Yeah.
Maybe I should explain this a little bit. When you have, let's say, two cardinally oriented structures, you can look in four directions: to the north, to the east, south, and west. But when you want to know where the North Pole is, and the structure is on the northern hemisphere, you will draw a line from the northern face over the globe.
Yeah.
Get a sort of line.
Yeah.
This line will pass the North Pole, the geographic North Pole. When I have a second structure, also cardinally oriented, I do the same. And these two lines cross each other. And this crossing point, that is exactly the geographic North Pole.
Oh, yeah.
Yeah.
Like the
It's
crossing
how-
of those two airplanes that you were watching in the
Yes,
sky
going back to this.
over the beacon. Maybe
Exactly.
this is the time to share screen again, so you can show these structures and how you have drawn the lines from them to the different positions of the North Pole that you have found in your research.
Yes, let's do this. I can go back. Sorry for this.
Yes, there you go.
Yes, this is the famous image.
The famous image. Yeah.
Yes, and this is of course not fully mathematical, but it is for people who have some difficulties with math to visualize this.
Yeah, it's very
How does
intuitive.
it
When you see it moving like this, you can
Yes, how does
understand,
it work?
okay, so the North Pole has been
Yeah.
moving from the south to the north then, from our perspective.
Yes. And how did I came to this 47.1 reference line?
Yes, this is the
Also-
longitude that all these North Poles are placed on.
Yeah. And this is also not a very long story. I can explain it in short. When you have a big database, you can calculate the average, let's say, intersection point of all these pyramids that are located everywhere around the globe. And this crossing point is on the southern tip of Greenland.
Mm.
This is the big point, the big node. This is around this pole 4. that you
Pole
see.
number 4 in your
Yeah.
assessment here, yeah. So when is that in time?
That is not directly timed. This is, let's say, I have 2 points. I have our current North Pole.
Yeah.
This is this red dot with the N. It's above Greenland.
Yeah.
And I have this second, very dense, large node. And I can draw a line between them. And I can extrapolate this line further down south. And then start to calculate the amount of intersections that this line has with ancient structures.
Yeah.
It might be perhaps something difficult to explain understand for people, but let's say this imaginary line is my reference line to make the amount of calculations. Okay, that's just
Yeah, and just to make
take this as
things
an
clear here,
exercise.
the oldest structures here, according to this assessment here, where you have checking the orientation of these structures, the oldest ones are the ones that are aligning with the southernmost pole on this graph.
Yeah.
And that's, if you see the graph on top there,
Yeah.
that is the rhythm of ice ages, as far as I understand it.
Yes.
So the last ice age that ended some 10,000 years ago, is that the tip of the graph to the right, or
Yeah, let me explain. Let me explain.
Yeah.
So I did all this math work, and I found a rhythm of very dense intersections. And this is these 4 red dots. pole 2, pole 3, pole 4, pole 5. And there's a rhythm. And then I started looking, because these changing of poles, of geographic poles, suggest climatic changes. And so the best place to look for climatic changes is this Antarctic ice sheet, because it goes back almost 500,000 years in time. And projecting the distances of the poles over the climatic changes. So you see this graph left, top left.
Yeah.
This is XL, and this S, then is M, and then is L.
Yeah.
It's the same rhythm as the distance between the poles.
Okay.
And these are two different patterns, because I have a pattern of ancient structures, and I have a pattern of climatic changes taken from the South Pole. And they fit onto each other as a rhythm. And I can calculate, of course, how much probability two of these independent patterns match onto each other.
Yeah.
And that is my, let's say, starting point. I can say with a 99.6% certainty that there is a relation between the two. Not 100%. 99.6%, 0.6%.
So every new position of the North Pole corresponds with an ice age period.
Yes.
And you have gone back four ice ages or 5 or something?
I went back to 350,000 years ago.
Yeah.
There is, of course, a pole 6.
Okay.
But I was not able to prove this pole sufficiently. So, and this is, of course, a little bit frustrating, but it's just a fact that it's not able to prove this. But it would be let's say the further most left position on the graph, the top left graph. But the position I found as a relatively weak proof also suggests the same rhythm. So the probability just jumped up to 99.9 and so on % with this 6 pole. But okay. But the interesting thing is that these 5 poles of, let's say, 4 ancient poles could explain the eccentricity of the ancient ice sheet.
Yes, definitely.
Because when pole 5 is the oldest, the ancient ice sheet could start building from this position all the way around its pole, and then slowly climbing up over Greenland.
That would explain why Greenland is so completely covered in ice, which doesn't really make sense today, because it goes pretty far south, actually.
Yeah.
The southern tip of Greenland is on the same latitude as Stockholm, where I'm living now.
Yeah, exactly.
Yeah.
So why is Greenland covered in ice? It's a good question. It's also not explained. So the theory condenses all kinds of unexplained phenomena onto one theory.
But it seems to me more like there's a rhythm within one long ice age. I mean, I'm not an expert on ice ages and how long they are. Maybe I've heard somewhere that the last ice age lasted at least 100,000, maybe 200,000 years. So maybe within this time frame you have a time frame here of about 350,000 years. Maybe within that time frame there was a constant quote unquote ice age, but it was there was a rhythm of colder and milder periods, and so on. Exactly. And they happened when every time the pole shifted, which was also corresponding to an expansion of the Earth's crust, which is the next thing you're going to talk about, I guess.
Yes, I will come to the Earth expansion.
Yeah.
It's of course outrageous idea, but
It
I
is.
was first want to explain a little bit about the ice age graph on the top left, because you see a clear pattern as well. It goes very steep up to a point, and then slowly goes down, steep up,
Yes, it does.
down, and so on. This is also a pattern. And what
does it show? What does that graph show?
it shows the say the upward flank.
Yeah.
Shows the recuperation of the biosphere
Uh-huh.
after a crustal deformation.
Mm-hmm.
So the crustal deformation is the downward flank, and the upward flank. Then upward flank is the, let's say, recuperation of the whole biosphere, changing to adapting to a changed climate.
I see.
Yeah. Of course, this is a enormous catastrophic for the Earth and everything that lives on it.
Yes, I have questions about that.
Yeah. There is to come to expansion, I have to explain a little bit more about the probability that these two patterns match onto each other, because the graph on the top left comes from the South Pole.
Mm. And the South Pole, now this is interesting, the South Pole has not moved.
Has not moved. And it's also the conclusion, because if the North Pole moved so much, and the South Pole moved as well, you will never find this matching pattern. So my conclusion is that this proves that the South Pole did not move, or hardly move. And that is, of course, directly comes to your conclusion. Okay, how is this possible? It only can be expansion. What else can it be?
Yeah, what else can it be? It can be, well, since it's a sphere, the Earth is a sphere, it has to be some kind of deformation.
Yeah, and there are, of course, there are expansionists who explain the Earth expansion from looking from isochrons. I can, of course, pull this up as well. I'm back again. I can show this this isochrons on our planet, and let's perhaps talk a little bit about this as well. Let's have a look.
What was that again? The ice, what did you say?
Isochrons.
Isochrons.
Isochrons. The growing Earth model. Yeah. Let me say about this map.
Mm-hmm.
Can you see it?
I can see it.
Yeah. This isochronic map of the ocean floor. An isochron means iso is the same, and chron is time. Yeah. So these red areas are of the same time, and the green areas are also of the same time, and so on.
Yeah.
And this should be the proof that Pangaea had existed, and so Africa joined to South America, and India was against Africa, and Australia was against Antarctica, and so this Pangaea. I guess most of your listeners know this Pangaea idea.
Yeah, and I've always wondered why. I mean, why did suddenly all the continents started to move around on Earth? It never made sense to me. But this theory actually makes sense.
No, there's no mechanism as well. And there were even, they call Pangaea the supercontinent. There were even 6 supercontinents before Pangaea.
Yeah.
Yeah. This is a geological idea. But of course, this is difficult to prove. But what is, let's talk about expansion. There are a lot of expansionists who say this proves expansion, so that, for example, Australia and Zealandia, that is east of Australia, was against South America.
Mm-hmm.
And so you can all put this on one globe, but a smaller globe.
Yeah, it's going to be a much smaller globe.
Yeah, much smaller globe. About 65% of the current diameter. So
Yeah.
it's not very small, but of course volume goes to the power of 3.
About the size of Mars, perhaps, or Venus, maybe? Venus?
Yeah, something
Venus
like
is
that.
bigger than
Yes.
Mars.
Yeah, I don't know exactly, but I didn't looked into this. But I had some debates with expansionists about their ideas, because there is a problem with their theory of expansion, of timing the expansion.
Mm.
This isochronic map is made with a constant diameter in mind.
Mm.
So geologists made this with a constant diameter in mind. This is important to understand.
Yeah.
Because when you want to time an expanding Earth with this model, you cannot use this time bar on the bottom of the map.
No.
And why not? Because you're comparing apples with pears.
Mm-hmm.
So you have to, what you can do is you can say, okay, what I can say for sure is red belongs to red. It's from the same era, the same magnetic orientation. And green belongs to green, to keep it simple.
Yeah.
And
And what you can see, I mean, as a layman like myself, is that large chunks of the sea floor, which I mean, the parts of the sea floor that seem to be in between continents, is younger than other parts of the Earth. For instance, the landmass and also the parts of the oceans that are closest to the continents, which would indicate that, well, there might have been some kind of expansion, and these red areas didn't even exist from the beginning. It wasn't there. It just, and when it expanded, it kind of appeared. It just appeared. So I guess geologically, you can see that the middle part of the Atlantic, for instance, is what is it now, 10 million years old or something, and if you look on,
let's say officially not older than 40 million years old. So the oldest part, the Earth is 4.5 billion years old.
Yeah.
This can be proven by taking rock samples and so on.
Mm-hmm.
And I believe uranium dating. But the oldest part of the seafloor is officially not older than 180 million, maybe 200 million years old.
Yeah, and how do these experts, these scientists who are not expansionists, how do they explain that?
They explain it with the reorientation of the magnetic particles on the seafloor. So this is this so-called how do you say this? Ompoling, changing of the poles, changing of the magnetic poles.
The magnetic poles.
Yeah. And there is no, let's say, other dating of the seafloor than this changing of magnetic pole. There are a lot of problems when you look deeply into this paleomagnetic science with the dating of the seafloor. And there's a lot of controversy about the timing and the exact position of poles. And there is a very good book, I often promote this, written by Professor Emeritus of the University of Arizona, I believe, Robert F. Butler.
Mm-hmm.
And he fully explains how you come from a rock sample to etching it in a laboratory, to etc., to finally dating this. It's an enormous process. So geologists did this over the course of many decennia.
Okay.
And they finally could arrive to this seafloor map.
Yeah.
And it's a magnificent work, of course, what they did.
It is. But let's say, if I just want to make it simple here now, if you have a balloon, let's say you want to inflate the balloon, and you inflate it from, let's say, well, from there is a hole that you're supposed to inflate it from, and you blow your air inside into that, and that should be then, in this analogy, the South Pole, because the South Pole stays where it is.
Yeah.
And then the Earth, aka the balloon here, expands, and if you have a pattern written on the surface of the balloon, it will move away from each other. It will,
yep.
I mean, it will steer away from each other, and it will look differently, and there will be new, quote unquote, new areas created, because it's I mean, the tissue, the fabric of the balloon will stretch
yep.
but it will do that uniformly. But in your theory, as far as I understand, I mean, because in this analogy, in this example, the so to speak, north pole of the balloon would stay in the same place, wouldn't it? It wouldn't move. It would be the same.
South Pole. The South Pole.
Yeah, but even the North Pole, actually, in the balloon example, if you inflate it uniformly.
Yes, exactly.
So I mean, it's kind of like in your example here, the Earth isn't actually a proper balloon. It's been skewed in a way. It's been, I mean, the Earth has expanded more on one side than on the on the other. And why is that?
Yes, you said it very well. You can see on this map that in the Pacific, on the left of the map, this red area is much bigger than the other red areas. So
I can see that. Yeah.
If the expansion theory is correct, then the red and green areas expanded much more, and so this expansion was not uniformly. And this expansion could explain, not on a flat map, but when you project this on a sphere, you can see that from its expansion model, Greenland was pushed over the North Pole.
Yeah.
And I can take you to another picture. And that is this one.
Oh yeah, that one's cool. Yeah, you can see yeah. There's a ring around Antarctica.
Yes, this exactly confirms that Antarctica stays on its place, because you see this expansion ring fully around Antarctica, and this green and red and a little bit yellow.
Yeah.
So when expansion is correct, it was somehow moved and pushed from the South Pole.
Do you have any explanation for why it was moved and pushed from the South Pole, or is it just is that just a coincidence or a random? It could just as well have been some other point on Earth.
This becomes a little bit more difficult area. There are two competing theories. I had a podcast with Demystifying Science a few months ago, and they have an explanation from a guy named Donald Petit. He was an astronaut, and he said it might have been decompression. So the atmosphere was much denser, not liquid, much thicker, denser. And so this dense atmosphere could push, you can do calculations of this, push the Earth smaller. And if you push this smaller, then you can join all these continents together. And this could explain why dinosaurs grew so large. Because they were supported by a much denser atmosphere, like a whale in the water.
Yeah.
But of course not.
And also the density was, I mean, gravity was much lower because the Earth was smaller. That's also one factor.
This is one competing theory. Let's say the density was the same, but the atmosphere was thicker.
Oh yeah.
So this thicker atmosphere pushed
Mm.
the Earth smaller.
The gravity was
yeah,
probably
similar.
lower. Similar. Okay.
Yeah.
Okay.
And then the other is expansion, and most expansionists cling on to this idea that somehow the Earth gained mass over time and grew from the inside.
Mm. And that's the question. I mean, from where does this material come? How can it grow from the inside? That's a very difficult one to understand for a layman.
Yeah, the most likely explanation is from the sun, coronal mass ejections from the sun that are caught in the magnetosphere. So the magnetosphere is pretty much larger than the Earth itself, about 4 to 5 times larger.
Mm-hmm.
So when a coronal mass ejection, several types of flares, coronal mass ejections, they have several classes of largeliness.
Yeah.
The X flare is the largest one, and they also, like in earthquakes, they classify them in 1, 2, X1, X2, up to X10. But then, of course, there are, like in earthquakes, there are X flares that fall off the scale.
Mm.
But when such a large coronal mass ejection hits the Earth, the magnetosphere catches all these subatomic particles. And these subatomic particles are guided through the magnetosphere to the flux lines, slowly into the core of the Earth,
Mm-hmm.
and then transformed into mass.
Yeah. So but on its transportation, on its way down into the core of the Earth, it's never manifested as matter. Then.
Not yet.
No, it's only when it arrives.
Yeah, subatomic particles are not, let's say, atomic particles.
No,
they can more easily travel into the Earth than of course, it is fringe science.
Yeah,
you have to.
it's very far out, so to speak.
It's very far out,
but it's very interesting. I mean, what do we know? We don't know anything. We don't have any clue about what happened.
We have no clue.
Planet. We have no clue. So why not? I mean, yeah.
Why not? But I tend to bend more towards decompression, because decompression explains it so well, and I will also explain why. Because these X flares caught into the net of the magnetosphere and are guided into the core of the Earth. It's a little bit artificially constructed. I want to have a theory for my expansion.
Mm.
But decompression, I think, wow, because the atmosphere could be blown away by a large X flare, bit by bit, and this could explain, let's say, that the atmosphere became less dense over time.
I just quit that. Yeah.
Thank you. So that the atmosphere became less dense over time through these X flares that hit the Earth. So the Earth atmosphere loses mass.
But why does this happen recurrently? I mean, one can understand that it happened once, but it seems as if it's happening rhythmically almost.
Rhythmically, yeah, it seems to happen rhythmically. There is a rhythm of about 500 years of a big event.
500,000 years or
500.
Oh, 500 years.
Each 500 years.
Okay.
So every time, like let's say a little hit of hail to the Earth, losing every time a little bit mass. Okay. So this process takes on. It continues almost invisible. And so slowly losing atmosphere, slowly losing compression. So the Earth starts to decompress. It's a very nice theory of Donald Petit.
So decompression is your main theory about
decompression. Yes, I tend to lean towards decompression.
Yeah, that's why the Earth has been expanding
Yeah, but there is, of course, we talked about the time frame of these isochrones of the ocean floor.
Yeah.
These red and these green areas. So you cannot use this time frame for your decompression or your expansion because the isochrones are made with a fixed diameter in mind.
Mm.
And this you must understand this intuitively.
Mm.
You cannot use this.
Now, are there any? I mean, you say you're a spiritually inclined person, but are you also into reading ancient spiritual texts, for instance? And in that case, are there any references to this Earth expansion in ancient texts? Have you seen anything like that?
Yeah.
You have?
Sure. Yeah. I read the Emerald Tablets of
Thoth, or
he talks about
Hermes Trismegistus in Greek, I guess.
Yes, exactly.
Yeah.
He talks about this. He talks about the earth rumbles from the inside, and then water came up, and then the captain from the sky took me and brought me to Kem, to ancient Egypt, and I built my pyramid. So,
yeah, but that was maybe late. I mean, there are so many discussions about what really happened. That could have been the Younger Dryas cataclysm that many are talking about, and that's only 12 to 13,000 years ago. So there was no pole shift at that time, was it? I mean, that was earlier. So
no, the Younger Dryas, I can show. I'm the guys of the Younger Dryas thankful for, let's say, shifting the paradigm.
Yeah.
Paving the way for another understanding, another look to ancient history. But the Younger Dryas is not the only dip on the ice sheet of Greenland, because there are 12 or 14, 13, 12, 13, 14 similar dips found on Greenland. So the Younger Dryas dip, when you Google on Younger Dryas, you will find a graph just 15,000, 20,000 years, short time. But the ice sheet on Greenland...
Yeah, well, I think 1,200 years, actually, they say. I mean, the period itself is supposed to have been about 1,200 years long.
Yeah, the period itself. Yeah, I know.
I'm sorry, maybe you were referring to something else.
No, I'm talking about this Younger Dryas dip is taken from the ice sheet of Greenland, the temperature change.
Okay.
And so they can reconstruct temperatures, not only from this ice sheet, but also from tree rings and so on. So this shows a clear dip in temperature. But what I want to say is that back to 15,000 years approximately, you can do this with tree rings. But further back is impossible with tree rings.
Yeah,
you can do this with a Greenland ice sheet. It goes back approximately 100,000 years. And in this period of 100,000 years of the ice record of Greenland, you see multiple dips of similar size as the Younger Dryas. So this questions, of course, what does the Younger Dryas mean exactly? Is it a comet impact? Or is it just the stopping of the ocean current? So I want to always promote you have to expand your view to be sure about the claims you do about because there are books full of Younger Dryas and civilization stops. It's good. It's good for shifting the paradigm. It's good for paving the way of another way of thinking, that ancient cultures are much older.
Maybe it's not the whole story.
It's not the whole story. because I think the Earth was hit by multiple cataclysms.
Yeah.
Comet impacts, stopping of ocean currents, of Earth crust deformations. So the Earth is not a. We think the Earth is a tranquil place, but it's not. We are here flourishing because it's a tranquil place now.
Yeah, it's been tranquil for 10,000 years, but maybe we're soon out of that.
Yeah. Where is our civilization over in when a large cataclysm hits the Earth? What is being left of our civilization in 100,000 years from now into the future?
Not much.
Not much.
Since we don't build buildings with large stone blocks, which they did before,
Yes.
we only build with concrete and steel, and that will perish.
Yeah, concrete will be pushed from the inside by corroding iron.
Yes, there will be nothing left in 100,000 years.
Crumbles, yeah.
Definitely.
And this natural stone, structures made from natural stone, can last for millions of years.
Yeah, yeah.
Because,
now, in these, by the way, do you think that these comet impacts, if there were comet impacts and sea current stoppages, as you say, and were they coinciding with crustal deformations, or were those different kinds of cataclysm, different things, or were they
different?
Do they go together in some way? For instance, do comet impacts trigger crustal deformations? That's one side question, for instance.
Don't know. I don't know, no. To be honest. No, I think there can be multiple cataclysms behind each other at the same time.
Yeah.
Different possibilities. And there is a curious coincidence with eccentricity and ice ages, because that's what I didn't mention in the beginning.
Yeah.
Ice ages and eccentricity go together. That's interesting.
That they go together.
Why is this?
I don't know. I was going to ask about why. I mean, I haven't really understood why this deformation actually creates ice ages. Why does the climate change? Because I mean, the radiation from the sun should be the same anyway, no matter what. But yeah,
no, it's not.
Let me hear.
Radiation varies over time, and there are a lot of theories about this, but we don't know much about the sun over, let's say, 100,000 years ago.
Yeah, but you say that the deformation, the crustal deformation per se, is the thing that creates ice ages and changes the climate. Yes. So how is why? What's the mechanism there?
The mechanism could be expansion or decompression, and so decompression could be much younger than we initially think.
But why would decompression lower the temperature on Earth and create all this ice?
It should be no lowering. It is a change in because this reconstruction of the climatic changes in the ice sheet, it's a reconstruction, is also made with fixed planet in mind. So when you, of course, the geologist thinks the planet is a uniform body.
Yeah,
it's constant in position, a little bit Milankovich cycles, but the rest is constant. So diameter is constant, the geographic pole is constant, and then when you start drilling in the South Pole ice sheet and start to reconstruct the temperature changes with this constancy in mind, but it were not constant, it were large deformations, then you will reconstruct automatically this deformations when you have this constancy in mind. Can you follow me?
A little bit, yeah. I try to see before my eyes how this Earth is rotating, and then it's expanding more on one side than on the other, and then suddenly the area which is cold gets bigger, and but it's a bit tricky to see.
It's tricky, yeah. It's tricky. And I did not dive into, of course, a little bit, because people expect. I explained something about how this is possible, so I dived into this. But I stick more to the pattern matching, because I believe in when pattern match onto each other, you can say they belong to each other with a probability. And how this exactly works, that is another step.
Yeah,
it can take
but the
many
pole
decades
shifts, as you say, the pole shift, as you've been explaining, and the eccentricity of the ice sheet, that makes perfect sense in your model, I must say, when you explain that. So that's good enough.
Yeah. And I want to say a bit back to, did you find something in ancient text? I'm not a Bible guy. My grandfather was a professor in theology, and archaeology, both. And he, so I'm a little bit, he could read cuneiform tablets as well.
Cool.
We translated them. I was captured by this vitrine closet of him with all these ancient tablets inside. And I was intrigued by this. And so I had a little bit basic from Bible and ancient Sumerians, and I had a very young interest in this. The Bible says about something about expansion, maybe, because the earth was flooded with water. And of course, I'm writing my book because I need to explain this all in detail. It's difficult to explain such a big theory in an interview of 1.5 to 2 hours. I try to do my best, of course, but that is why I'm writing my book. Because when the earth expands from, let's say, a pure landmass, so the earth was 65% of its current diameter, all the land masses were joined together. There was very little water, just small lakes and a few seas. Mediterranean was there. And so it started to expand or decompress somehow. And there is a material that is called, I just now forgot it. I was writing a few days ago about it. I wrote it in Dutch, so I have to translate it. There's a mineral inside the earth that can contain water under pressure. I just forgot the name. And never mind. And there is currently
shale, maybe shale.
No, not shale. No, it's deeper
down. And it's not iron, and it's not nickel, and it's not. No.
I can just look it up.
Okay. Anyway, it can contain water under pressure.
Yes, it contains water under pressure.
And when the earth is decompressed, then the water comes out. Is that right?
Yes, because it can only contain water under pressure. From the moment the pressure is released, when the crust starts to break open deeply inside, this material releases pressure, and the water starts to bleed water. And it comes in big amounts from these cracks all over the earth. And this could explain that the earth was totally covered with water.
Yeah, because that's a good question. Otherwise, I mean, I was going to ask you about that. Talking about floods, I mean, if the earth expands and the floors of the seas are the parts of the earth that expands later, then I mean, where does all the water come from? Does it all of a sudden start raining? But this is an explanation then, that it actually comes from the inside to a large extent. Then
it's called ringwoodite. Anders,
what's the word?
Ringwoodite.
Ringwoodite. Okay.
Ringwoodite can contain about 2% of water of its own mass, so about 8% volume, and that's a lot.
Yeah.
There's currently about 3 times the oceans inside the crust in water.
Fascinating.
Fascinating. So when you look through your eyelashes to this idea, the crust starts to crack open. This ringwoodite starts to bleed water in large amounts and flushing over the whole Earth. This is what Genesis says. And of course, the story of Noah. But this story,
But
the Bible is not invented
floods.
from itself. It comes from ancient Sumerian texts. So, the Earth is covered in water, but it starts to expand further from the ocean floor. So there comes volume available in the ocean floor for the water to flow back to the ocean. And so the land becomes available slowly again. I think this is what could have happened. Yes.
Yeah, and several times then.
Several times over.
Yeah, several times over.
Yeah,
yeah, that's fascinating. I mean, during these expansion periods, which have lasted for what, maybe hundreds of thousands of years or thousands of years, or depending on.
I think about 1 million years, perhaps 2 million years over a longer period.
Okay, so it's not from 1 week to another, but I mean it's a period where I assume that there must have been many big earthquakes and volcanic eruptions and all kinds of catastrophes going on. So it must have been pretty tough for any life that was on the planet during these periods of expansion.
Yeah, it was very difficult, I think, but there is also evidence that suggests that people still kept on building ancient structures. And so there were certain parts in the world that were not, don't want to say tranquil, but livable.
Less affected, yeah, okay.
Less affected. So it was possible, but of course it was not a calm place to be on Earth during this 10,000s of years.
Yeah,
it's a long time.
Okay. And it will probably happen again, as far as I understand. I mean, this wouldn't just end, would it? This
no, there is not. We had the Carrington event in the
1859. Yeah.
So this Carrington event could have blown away a little bit of the atmosphere. We don't know because it wasn't measured. How much did we lose of atmosphere?
So that's the decompression thing. Yeah. Okay.
Continues over and over. We could still lose a little bit atmosphere, so a little bit decompression. But I don't know. I still have to dive more deeply into this topic because my research is yet not done, of course.
Yeah. No, this is all very, very fascinating. It's a bit complicated. I think people need some time to just ponder this and let it sink in to understand what this is. And we'll get back to your website and all that so people can look for themselves. But if we talk a little bit about the future and science here, what science disciplines will have to change when this knowledge, if and when this knowledge becomes mainstream? It seems as it's going to change almost every Earth discipline, isn't it?
It hits a lot of disciplines. It's a good question. What has to change? Let's first look at the ice ages and what caused the ice ages. And it's now assumed that CO2 levels caused this, but we know very well for sure that CO2 lags on temperature changes. So when something lags, it is not the cause.
It's not the cause.
Not the cause. And it lags about between 500 to 1,000 years on temperature changes. So it's a big lag. So it follows the changes. It follows the events of the ice ages. That's the first thing that we have to look at. And when a climate skeptic says, okay, this CO2 currently causing climatic effects is bullshit, because when we look at the ice ages, They were also changing CO2 levels. I say, and this is what I explain in detail in my book, CO2 has two faces. It's a coin with two sides. When you look at the ice ages and try to take this back from the ancient past to our current time, with all our machineries and all our pollution, you're doing a wrong job.
Mm-hmm.
Because these events were caused by crustal deformations. And CO2 is a heavy gas. And the average density of the combined nitrogen and oxygen, these combined masses, are lower than CO2. CO2 has the trait to stick low to the atmosphere, low in the atmosphere, and it definitely has the trait to block back radiation at night. And so this, I think, this discussion of climate change and so on, that we have to do something, is a little bit frustrating because we don't seem to understand each other.
Mm. Yeah, it is frustrating. I'm also interested in that issue, and
yes. So what has to change in science? First, we have to acknowledge that crustal deformations definitely happened in the past, and that this caused ice ages. And ice ages were not caused by CO2. So you cannot use this as a septic to throw away what humans are doing to the planet.
Skeptic, yeah. Mm.
Skeptics. Yes.
Yeah.
Skeptics use this always. And there are a lot of skeptics.
I know.
And
then, of course, you have all this archaeology and paleontology and all these disciplines that will have to change as well.
Yeah, I talked to an archaeologist, and I said, your timing of Stone Age, Bronze Age, Iron Age is the same as the corrosion rate of materials. Mm-hmm. So there was an Iron Age, but beyond the Iron Age, you don't find iron because it's all corroded.
Yeah, that's true.
You will find bronze.
Yeah.
So you assume you're in the Bronze Age. And I understand you, said to him, because there's no proof that it's otherwise. And then bronze corrodes and you find stone. And you go into the Stone Age for hundreds and thousands and millions of years because no other material is left.
Yeah.
Stone.
It's a bit naive, isn't it? I mean, just as you put it out now, when you say it like this, it's obvious that that the experts, so-called experts, they have just gone for the what's obvious. I mean, the corrosion speed of these materials, which is
corrosion speed is one thing, yes.
Yeah.
And then there is another thing, that archaeologists are digging deep below the surface to ancient structures, sometimes 4 or 5 meters below the current level, ground level.
Yeah.
While geology very well knows that the build-up rate of soil is about 1 to 1.5 meters every 100,000 years. Of course, you could say, okay, this was caused by the flood or mud flows. It's always possible. But there is a too big pattern for only mud flows to hide it behind mud flows.
Yeah.
So there is a clear sign as well, besides orientation. There is a sort of pattern that the deeper you become, the more differently oriented structures also become.
Yeah.
There's also a pattern. There's a lot to say about this theory, of course. And back to your question, what has to change in science? Archaeology is, of course, one of the most stubborn sciences of all.
Yeah.
Because you're not allowed to enter the scene, to look over their shoulders. What are you doing? How do you salvage everything you find? How do you date everything you find? And how do you interpret and how do you measure your findings? And I would say a little bit about carbon dating, and there's another method, fluorescent dating. There were tusks of mammoth found recently, and they were dated with carbon dating and then with fluorescence dating, and they gave different results. But this fluorescence dating can only be used with specific, like ivory and this sort of things. And so the tusks of the mammoth appear to be between 40 to 50,000 years old, while carbon dating gives something like 15,000 years old. So carbon dating is tricky.
Yeah.
Tricky because when you go beyond the calibration curve of carbon dating is currently around somewhere 12,000 years old, and everything beyond this 12,000 years old is into the mist. You have to draw a straight line, and start to date it then this way back. So this is sort of it's unscientific way of dating.
Yeah.
So a lot of things to discuss with archaeologists, and of course, it's entrenched science.
It is.
Even
do you think that society is ready for a new view on these things? And a follow-up question within that question: do you think what will be the trigger if there is going to be a sea change in this field? What will be the trigger, do you think? Do you see any things like that? Like, I mean, the discovery of Göbekli Tepe, or the dating of something that will upend everything. Is there any kind of trigger like that you see before you?
I don't have currently a clear trigger in front of me. I think it is a very slow process of changes and findings, because Homo sapiens, as we are over 350,000 years old with our brain capacity. So what prevented ancient humans from doing the same as we did?
Nothing. Well, apart from some earth deformation of the earth crust, some once in a while, but
yeah, and you need, let's say, for over a longer period of time, stability to build as a human being, to build a society. It takes a few thousand years to build onto your basic foundations, to build a solid society. It takes time. You cannot, as brilliant as people can be, even 300,000 years ago, they cannot build from scratch. So they have to build slowly over generations, the society. And this society can be wiped away within a matter of years.
Yeah. Do you receive any support from the mainstream scientific community in secrecy, perhaps?
Sometimes, yes, but not openly. No. It's too big a step. It's a step in archaeology, a big step. It's a big step in geology. It's paleontology. It's all the way down. It's too much to digest for a scientist, and a geologist is also trained in thinking in all these history tables. This color table with all these time frames.
Yeah,
there's a 95 periods you have to learn from your head, and all these timings a million years ago, and so on. When you learn this as a geologist, you already become a little bit entrenched into a way of thinking.
Yeah.
And this is the first thing geologists have to learn, this timetable. And this timetable might be wrong, might not be correct.
We see this entrenching all too much all the time. Now, Mario, Martin, where can people go to find your work if they want to know more?
Thank you for asking this. They can go to mariobuildreps.com and they can always send me questions and leave comments or perhaps email me. And my email is everywhere in the webpage, buildreps@gmail.com.
Okay, wonderful.
And
I'll put links in the description box, of course, also. So, Mario, Martin Tege, Mario Buildreps, thank you so much for being a guest on the show. And I mean, it's been fascinating and an education, as I sometimes say. Very good conversation. Good luck with your groundbreaking work now.
Thank you, Anders, for having me. And I hope you enjoyed it. And it was not too complicated for your listeners sometimes.
I think it was fantastic.
Okay, thank you.
If you like this video and other interviews and talks and stories on Mind the Shift, please like, share, and subscribe. And most importantly, become a patron. Click on the Patreon link in the description box if you're on the cell phone or in the banner if you're on a computer. I appreciate all the support. It allows me to make more and better content. Thank you.